Okay, what if I told you that there's this huge, hidden potential locked inside almost every single student? And what if the way we've been teaching for, the last 100 years or so is actually the very thing holding them back? Well, today, we're going to dive deep into the incredible science of how we actually learn and figure out what it takes to unlock all that potential.
So let's just kick things off with a simple question. I think we all kind of know intuitively, right, that one-on-one tutoring has got to be better than being one of 30 kids in a classroom. But how much better are we really talking about? Like, is it 10% better, 20%? Let's see what the actual science has to say about this. Get ready for this, because the answer is it's just staggering. It's 98%. Yeah, you heard that right. A landmark study back in 1984 by an educational psychologist named Benjamin Bloom, he found that the average student with a personal tutor performs better than 98% of students in a typical classroom. I mean, that's not a small difference. That is a monumental, jaw-dropping gap in human potential.
And you know what? This massive gap actually has a name. It's famously known as Bloom's 2 sigma problem. Now, 2 sigma, that's a term from statistics, and it basically represents a huge jump, 2 standard deviations. To put it in plain English, think of it like this. It's like taking a completely average student and transforming them into one of the absolute top performers in the class. It's a massive leap. But Bloom, he didn't see this as some kind of failure. Nope, he saw it as a challenge.
So Bloom's challenge was pretty clear. Can we figure out a way to teach groups of students that's just as powerful as one-on-one tutoring? Because he believed that if we could crack that code, it would completely change popular notions about human potential. He saw this as the key, the key to unlocking a level of achievement that we've usually just reserved for the gifted few and making it possible for pretty much everyone.
But here's the thing, for decades, we've really struggled to solve this problem. And what's weird is that in recent years, it almost seems like we've convinced ourselves the problem doesn't even exist anymore. I bet some of you are thinking, hang on a second, if there's this huge learning deficit, why are grades going up? And that is a totally fair question. It points to this modern paradox that's kind of hiding the real issue. So let's take a look at the data.
Okay, so what's so interesting about this chart is the huge mismatch it shows. This, right here, is grade inflation in action. You can see that while average high school GPAs have been climbing steadily up, standardized test scores, which are, let's be honest, our best measure of what students are actually learning, have stayed flat, or in some cases, they've even gone down. So we're handing out higher grades, but achievement just isn't keeping up. And that creates this really dangerous illusion that we're learning a lot more than we really are.
So what is going on here? If grades are going up, but learning is going down, well, we're basically fooling ourselves. And this brings us to a really key concept that researchers call the illusion of learning. It perfectly explains why so many of us, and I'll definitely include myself in this, are drawn to these study methods that feel super productive, but in reality, they achieve next to nothing.
This is just fascinating. Look at this. On the left, you've got all the stuff that feels like you're learning, right? Passively listening to a lecture, highlighting your textbook, rereading your notes over and over. It's all very comfortable. But then, on the right, you have the things that actually work. Actively solving problems, spacing out your practice sessions, forcing yourself to pull information out of your memory. These methods involve something scientists have a great name for: desirable difficulties. It's a brilliant term, isn't it? They feel harder because they are making your brain work harder. And that struggle is precisely what forges real lasting learning. And check this out. There was this 2019 study on physics classes at Harvard, of all places, and they found something pretty incredible. The students in the active learning classrooms, they learned more, but, and this is the crazy part, they felt like they learned less. So that mental struggle, that bit of confusion you feel when you're really wrestling with a new idea, that is not a sign that you're failing. That's the feeling of your brain actually building stronger connections. That easy, comfortable feeling you get from passive learning, it's just an illusion.
All right, so if our old, comfortable methods are basically flawed, what's the alternative? What does the actual science of learning tell us we should be doing instead? Well, the good news is cognitive science has given us a pretty clear blueprint. It's identified several super powerful, evidence-based strategies that literally anyone can use. Let's just break it down into 3 core principles. Okay, number 1, practice actively. Real learning isn't a spectator sport. It happens when you are doing things. You're solving problems, you're applying concepts. Number 2, ensure mastery. Think about it. You wouldn't build a second floor of a house on a shaky foundation, right? You have to master the basics before you can move on. And number 3, space out your review. This one is so crucial. It is the only proven way to fight our brain's natural and, let's face it, annoying tendency to forget things.
So let's dig into that first one, active practice. The most effective form of this is something called deliberate practice. Now, this is not just mindless repetition. No way. This is focused, targeted training, right at the very edge of your abilities, and it's all designed to improve very specific skills. A great example is a musician who practices a really difficult passage over and over and over, instead of just playing the songs they already know by heart. It should feel like a real workout for your brain.
All right, next up, mastery learning. This idea, which was also a big deal for Bloom, is actually really simple, but it's also profound. See, in a traditional classroom, the clock is the constant thing, right? The bell rings, you move on. But everyone's level of understanding is all over the place. Mastery learning completely flips that around. Here, understanding is the constant and time becomes the variable. Students have to prove they get a concept before they're even allowed to move on to the next one. This is how you make sure there are absolutely no gaps in the foundation of your knowledge. And finally, we've got spaced repetition. I absolutely love this quote. Spaced repetition is like weightlifting where the weight is the weight. It's just such a powerful analogy. See, forgetting isn't the enemy here. It's actually a necessary part of the learning process. That little bit of effort your brain has to use to recall a memory after some time has passed, that's what makes the memory stronger. That struggle, that weight, is literally the weight that builds your mental muscle.
So this leads to a pretty big question, right? If these principles are so powerful, and we've known about them for decades, why isn't every single classroom using them? Well, the answer is actually pretty simple. For one human teacher, trying to do all this it's basically impossible. And this is where technology comes in and changes absolutely everything.
I mean, just try to imagine you're a teacher with 30 students in your class. To really implement mastery learning and spaced repetition properly, you would have to track a totally separate review schedule for every single student for every single topic they've ever learned. You'd have to create personalized practice for each and every one of them every single day. It is, and I mean this quite literally, an inhuman amount of work.
And look, this isn't just a theory. Some researchers actually tried to do a kind of stripped-down version of this manually, and what they found was that for just 2 small classes, it took more time and effort than a full-time job. And get this, that was for just one of these strategies, and it wasn't even fully personalized. It's not scalable, not with human labor alone.
But here's the beautiful part. What's an inhuman amount of work for a person is, well, it's trivial for a computer. Technology can automate this entire process. It can track every single student's progress on every single concept, all at once. It can deliver the perfect practice problem at the exact right moment to make sure you remember it. And it can guarantee that no one moves on without true mastery. To put it simply, it makes the ideal tutor, the one that can close that 98% gap, scalable for everyone.
And that brings us right back to where we started. Remember Bloom's challenge? To give every student the same benefits as a personal tutor? For decades, it seemed like an unsolvable problem. But today, when we combine the science of learning with modern technology, we might finally have the key. So the question I really want to leave you with is this. If we can finally close that 98% gap for everyone, for our kids, for ourselves, what does human potential truly look like? What are we all actually capable of?